All right, good morning. Welcome back to pre-calculus. So we are going to be talking about the sum of angles today. Now, I'm going to derive it for you. You do not have to memorize or be able to re-derive these formulas. And I'll put a link in my description saying where I got this from, because this is shamelessly stolen from another channel. It's blackpenredpen. He's excellent. And he'll do it better than I will. So I don't know why I'm recreating it, but here we go. Okay, and we'll talk a little bit about what's happening as we're going through. All right, so let me go ahead and do share screen here. Okay, there we go. All right, so let's get rid of all of that. Let's get rid of all of this. Let's just pop this up. Okay. So here we go. And it actually works for the board that I have. All right. So what we're going to try to do here is we're going to talk about the sum of two angles, the sine of like an alpha plus beta, the cosine of an alpha plus beta. Okay. And the whole purpose of doing this derivation here is to have you memorize, have you remember like the pain and terribleness of this, so that you can in the future, when you're tempted to do this, okay, you'll think to yourself, we went through this whole day of doing all this this derivation stuff. Maybe I shouldn't do this. So don't do this. Okay, that teacher will be very mad at you. Okay, so you're not going to get, if you do this, this is not, you, both of us are going to be unhappy. You're probably going to be more unhappy than I am. Okay, so don't do this. All right. I want to put this on here, put it in the mind of anybody. Okay. So what we're going to do here is we're going to go ahead and we're going to draw a little rectangle here. Okay. So I draw a rectangle. I'm going to change the colors of all of these in a little bit, but I'm going to go ahead and make this, I'm going to call this angle a beta. Okay. And we're going to draw another line here. Okay. I'm going to make this a perpendicular. Okay. So this is going to be a perpendicular line here. Okay. And this is my angle alpha. Okay. What I should do is I should do this. So bear with me. Sorry. Okay. Let's go with blue, green. Let's go with purple. Okay. We're going to have a little alpha in here. Okay. So alpha, that's this guy. Beta. Okay. I'm not trying to convert you. Okay, my statistics class always, we use alpha a lot, and they say it looks like a fish. By the time we get there, usually in the semester, it's about it's further in the spring. So they always convert me or accuse me of converting them to Christianity because of the fish. I'm like, it's an alpha, it's not a fish. Okay, it's just alpha. So I'm not trying to convert you. Okay. And then what I'm going to do is we're going to go ahead and we're going to make a little square here. We're going to finish our rectangle. So we're going to draw a little guy here. Remember, this is the right angle. Okay, we're just going to continue this piece along. So we've got some, right? We've got some triangles to work with. All right. And I'm going to go ahead and call this side here, we're just going to call this 1. Okay. So maybe I should do it this way. That pink's good. So I want to erase this. My linchpin here. And we'll say this guy here, this right here is a 1. And we'll just note that that is our right angle here. Okay. So if I just take this triangle out, okay, this one right here. Okay. What we're going to do, let's see here. What do I have? I have purple. So let's go with a pink hypotenuse. Okay. And we'll go with a, I guess we'll go with green here. So this side here, right? This one is actually the green one right here. Okay. And we'll go with orange for this piece. Okay. So this guy here, this is my orange. All right. And remember, this one was my alpha. Okay. So remember, the hypotenuse here was a length of 1. Okay. Wish I could macro these. Okay. Definitely, if you ever never watched them like by upspeed before, you should probably do that on this one. Okay, at least when I'm going through changing all the colors. Okay. So what I want to know is like what length, right? What is the cosine of this thing, right? What is the cosine of my alpha? And that is going to be this orange bit here, right? This right here. This is cosine of alpha. Remember, cosine of an angle is equal to its adjacent over the hypotenuse. Well, in this case, what's my hypotenuse? It's 1. So we have 1 times cosine alpha is equal to the adjacent. So this guy here, cosine alpha, that's my adjacent. And for the same argument, right, we're going to have ourselves a sine. Oh, that's not the right green. So you see, is it this one? I can't see that. I'm sorry. I thought I was going to be more clever than I was. This one. So this right here, this is sine alpha. Okay. So this guy here, this one here, this is sine of alpha. Okay. And in this bit over here, that's going to be cosine of alpha. Okay. Here, this is cosine of alpha. Okay. So we have this one middle triangle here with the alpha. We have this completely defined. We have the hypotenuse is 1. We have sine alpha. We have cosine alpha. Okay. Now we're going to turn down a little bit and we're going to go to the outside, this rectangle, or this triangle rather. Okay. So here we have, let's go ahead and change that one because that was an orange. Okay. So the hypotenuse here, right, that was me in orange, and this was cosine alpha, right? And here's my beta. Okay. We'll do beta for blue. Okay. Now, what is the sine of beta? Right? The sine is the opposite over the hypotenuse. Okay. So I'm trying to find this opposite side here. So this is the hypotenuse times the sine of beta. What's the hypotenuse? This is equal to the opposite side. Okay. So we have this cosine alpha times sine of beta is equal to this hypotenuse here. Okay, so we have, this is going to be cosine alpha sine beta. Okay, so this is cosine alpha sine beta. Okay, now what about this, the vertical part here? Okay, we'll use a different blue. Let's erase that blue and replace it with this blue. Okay, again, blue for beta. So the cosine of beta, okay, cosine of beta is equal to the adjacent over the hypotenuse. What's the hypotenuse? The hypotenuse was the cosine of alpha. Okay, so we have cosine of alpha, that's the hypotenuse, okay, times the cosine of beta. Okay. And that was equal to the adjacent side. So if I go over here and I say, okay, well, this is, let's see, this is cosine alpha, cosine beta. Okay, so this up here, this side, right? This was cosine alpha, cosine beta. Okay. Now we've got two triangles set up, right? We've got this middle triangle sorted, that's over here. We've got this outside triangle sorted, right? That's this piece. And now we're going to go through and we're going to do a little close-up of what's going on here. Okay, so what's going to happen? Back to this blue. All right, so we have there, there, there. So we have here's our top line. Okay, we've got this, and we've got that. That doesn't look like a right triangle, so let's make this a right triangle. Okay, so here we go. There. All right. So this is a 90-degree here, right? Because it's a rectangle. This is beta. This angle up here, this is going to be called 90 minus beta. This is a rectangle. This is the right angle here, right? So we can look at this. When we figured it out, that was a right triangle. And what I'd like to do is like, well, what the heck is this one? Well, this trio of angles, right, they have to add up to something. They have to add up to 180. So we've got the 90 minus beta plus 90 plus I don't know, and this has to be 180. Well, 90 and 90 makes 180 minus beta plus something equals 180. So we subtract out the 180s. We have negative beta plus I don't know equals 0. Wait, I think that this angle here, this question mark, this is actually beta. Okay. So here's what we're looking for. Right? This triangle, this tiny triangle up in this corner here, this angle here is beta. So let's go do a close-up of this. Okay, so we've got this, we've got this, got this. I should probably go ahead and change that to my green. Okay. So my hypotenuse here is actually the green one. Okay. And what was the length of this value? This was a sine of alpha. Okay. The angle here, right? Again, beta for blue. We'll do something like that. We'll call this thing beta. Okay, so that's where we are with this. And what I'd like to do is figure out, like, well, what are these sides? Okay, so what is the sine of beta? Right, the sine of beta is going to be the opposite over the hypotenuse. Okay, so this is the opposite side here is equal to sine alpha, right? Sine beta. So this side here, this is, should we do it in a different color or just leave it? Sine alpha, sine beta. Okay. Let's erase this side right here. Change it to, we'll get a different color. You could say brown for beta too. And we have to figure out what's the adjacent side here. Okay, so the adjacent side, right, we're going to say cosine of beta, right, is equal to the adjacent over the hypotenuse. The hypotenuse is this guy right here. So this is going to be sine alpha cosine beta is equal to the adjacent. So this length is sine alpha cosine beta. Okay, now you know why we did the close-up, because I wrote this in a way there's like, oh, what's this? This is, what do we say this was? This was sine alpha cosine beta, right? Sine alpha cosine beta. So that's this little tip right here. And then what color did we use? Blue for that one. It's unfortunate. Okay, but this guy right here, this is sine alpha sine beta. This is sine alpha sine beta. So we have 1, 2, 3 triangles finished. We have one more. Okay, we have one more triangle. So we need this bit here. Okay, so let's go ahead and make a little triangle here so we can work on it. Nice if that was straight. More straight. Okay, pretend that's straight. Okay, so this one here, right, that's the pink one. So actually, let's go ahead and replace that, put that back to pink. Okay, so that's the hypotenuse. Do you remember what the length was? Right, pink for 1. Okay. And we don't know what these guys are yet. Okay, but we have to figure out an angle. So the other angles in this corner, okay, the other angles in this corner, there was an alpha plus a beta up here, right? This was an alpha and then a beta. So this is 90 minus parentheses alpha plus beta. Okay, that's this angle. This angle here is a right angle. So we need to figure out, like, what the heck is this angle up here? Okay, and we're going to say, well, we have 90 and 90, it's 180. If minus alpha plus beta, this must be alpha plus beta here. Okay, that's what this is. So remember, hypotenuse is 1. So if I'm looking at this angle, okay, it's either an eye or satellite, depending on how you want to look at it. But satellites are eyes. This angle, the cosine, right, this adjacent side here, right? So we say cosine of alpha plus beta is equal to the adjacent over the hypotenuse. It's the hypotenuse. Hypotenuse is 1. So we have 1 times cosine alpha plus beta is equal to that adjacent side. Okay, so this is cosine of alpha plus beta. Okay. We go all the way back up here. So we have cosine of alpha plus beta. That's this spot right here. Okay, that's this length. All right. And now we'll come down here. We'll say, okay, well, again, we're looking at it from this point of view. Okay, what's the sine, right, of alpha plus beta? That's going to be the opposite of the hypotenuse. Okay. Wow, close. Okay, so we want the sine of alpha plus beta. That's equal to the opposite over the hypotenuse. So the hypotenuse, right, that was 1. So that was 1. So this side here, this thing here, this was sine of alpha plus beta. So this guy here, this is sine of alpha plus beta. Okay. And now we're going to do something magical. We're going to say, you know, I would really like that this side down here, this gray side, were equal to this blue side up on the top. Does that make sense? That if we have a square here, or at least a rectangle, that the sides, the top and bottom, would be equal? Okay, so what we're going to do is we're going to say, well, I don't want that. Okay, so we're going to say that the sine of alpha plus beta is equal to, okay, we have a cosine, right? Cosine alpha sine beta. We have a cosine alpha sine beta plus, okay, and then we have this round color here. So this was sine, this little side right here, right? That was sine alpha, cosine beta. Sine alpha, cosine beta. Okay. And then what were we doing with this? We were doing Mhm. So we had this red here, and we said the cosine of alpha plus beta plus, right? Because we want the two sides to be equal. So cosine alpha plus beta plus, again, with the blue, sine alpha, sine beta. Okay. Okay. Sine alpha, sine beta is equal to, I'm sorry, if I'm making you motion sickness, I'm really sorry. I have having to go back and forth, up and down to this picture here. But this side and this side, right, is going to be equal to this other blue cosine alpha, cosine beta. Okay, so this was equal to cosine alpha, cosine beta. So here, what I want to do is I want to subtract this, right? I want to put this thing on the other side. So that, I'll go back to blue and I'll stop dancing around all the screens here. So again, if I cost you some motion sickness, I am sorry. Okay, so this is cosine alpha, sine beta plus sine alpha, cosine beta. And then we have cosine of alpha plus beta is equal to, right, cosine alpha, cosine beta minus sine alpha, sine beta. I'm going to write this one more time to summarize what's going on. We're going to write it the way you're going to see it in the book. Alpha plus beta is equal to sine alpha, cosine beta plus cosine alpha, sine beta. And then this one's going to stay the same. Cosine alpha plus beta is equal to cosine alpha, cosine beta minus sine alpha, sine beta. Okay. So, excuse me. So that is our two sum of angles formula. These are the ones that you have to know. Okay. So the way I used to memorize these was we made a little chant. We'd say, okay, sine alpha plus sine of alpha plus beta, or sine of a plus b. We'd say sine, cosine, cosine, sine. So the first one would be the first angle. So sine, sine, cosine. So sine of the first, cosine of the second, and then plus cosine, sine. So cosine of the first, sine of the second. Okay. So we just say sine, cosine, cosine, sine. I went to a community college too, and you know, as I was driving into school every day, we would, you know, no, not we, I, instead of singing along to the radio there, I would, you know, chant my little sine of a plus b, sine a, you know, sine, cosine, cosine, sine. And the same thing with the cosine, 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 cosine minus sine, sine. Okay, so the first one, cosine, cosine, first and second, minus sine, sine. So if I broaden this out a little bit, and this is going to be one of those jerk sort of math book things. If I go ahead and put a negative in here, you can use this by odd and even principles. Okay, this is how you prove it as odd and even principles. Cosine alpha, cosine, sine alpha, cosine beta, plus or minus. The signs stay the same. So if you subtract the angles, you're subtracting. Okay, cosine alpha, sine beta. But notice with the cosine, the plus went to a minus. So the sine, SIGN signs, the signs swap. Cosine alpha plus or minus beta is equal to cosine alpha, cosine beta minus plus, okay, sine alpha, sine beta. All this minus plus thing means is that we just swap the order of the arithmetic. So if it's a minus b, then we're going to be looking at cosine alpha, cosine beta plus sine alpha, sine beta. Okay, so all that means is like if it's plus, if it's whatever the plus or the minus is, we're just going to swap the you know, it's either a sum. It's going to turn a sum into a difference. It's going to turn a difference into a sum. That's all we're saying with that. Okay, so don't get hung up on this one, because that's not where we should be. Okay, now I had an instructor that would tell us that, there are formulas you memorize for the test, and then there's formulas you take to your grave. This is an example of a formula you memorize for the test. Okay, it's not like rules of logarithms where you have to memorize those forever and ever and ever. Okay, it's not a quadratic formula. We have to know those forever and ever and ever. This is you have to know this for the exam. Okay, so I wouldn't I would memorize it for that, but this is not something you're going to have to memorize for the rest of your life. Okay, most of the time in more advanced classes, they might say, "Hey, do you remember sum of angles?" So that's why I asked. I know full well that you do not remember the sum of the angles. I remember you know that they exist. Okay, and I remember that you know that you can't just distribute them. But I do not expect my students to like have this at the ready. Okay, but they should be able to recall it. So it does come up once in a while. If you have a teacher that's going to put a problem that's going to require you to know this, they should probably tell you like, hey, you're required to know this for this exam. That's what I would do. Okay, so if if I was teaching a Calc 2 class where I was intent on using a problem where you needed this, I would let you know. It's like, hey, you're going to need to remember these formulas for this exam. But every other time I've used them, it's been in a homework problem. I've had the opportunity to look it up and then continue from there. Okay, and it doesn't happen often enough where like you have to have this like here ready now. So otherwise, because it doesn't happen every problem, it happens like every 10 problems. Okay, so if you didn't memorize it, it's not the end of the world. But it will be the end of the world if you don't memorize it for this quiz. All right, so memorize it for this one, but it's not like logarithms where you have to know with a capital K forever. All right, so what we're going to do here is I don't know how long it's taken so far. I lost track of my time. Okay. Yeah, we're going to go ahead and I'm going to pause here and I'll make another video when we start going through the problems here. They only give us 7? Yeah, we'll get through this pretty easy. Well, not easy, but we'll go through this. We'll go through this one pretty quickly. Okay, so I will do the homework. I will still go through the homework, do a walkthrough on the next video here. But there we go. All right. Thank you, and I will see you in the next video.